Welcome back. In my last video, I showed how to set up a basic project and draw some rectangles to the screen and how to get the player to move with the arrow keys, like this. And so the culmination of our efforts was basically what you have here. There's also some collision detection, and that prevents the player from moving off the edge of the screen. In the last video, I said I would be adding images. I'm going to go ahead and bring up the code here. Before I jump straight into images, this code is starting to get a little long for our main file. Let me close this window. Okay. You have game loop management with opening the game window and setting up the updater and renderer, and then you have a whole bunch of game logic, and then even within the game logic there's things about grids that we can probably move somewhere else to make the code a little bit more cleaner. So that's what I'm going to start with, because if we do that later it'll become harder. So one of the things that I usually do in games like this is I create some sort of scene object, and I'm going to do that now. I'm going to create a class called placing. Now what a scene object does is it basically has two methods on it: update and render, which is the two phases that game window has handlers for: set updater, set renderer. And so what I'm going to do is I'm going to transfer the contents of these two methods to our placing object. And we have some setup here. The setup sets up these grid and player variables, which are used by these methods here, and so these will have to be fields on the placing object. So the first thing I'm going to do before I move the updater and render is I'm going to move all of this into the constructor of placing. And these are still local variables, so I need to declare these as fields first. And then a field uses the prefix this dot, a lot like Java or C#. Okay. And then I'm going to move the updater and renderer. Okay. Now that grid and player are fields, I need to update it everywhere. So grid is used here, here. I think that's it. Player, I think, is used in more places. Here, 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 and here. I think that's it. There's also input state as an argument, so I need to add that to the update function signature. And here graphics 2D is also used. So how that looks here, I don't need this comment anymore. How this looks here is I'll have some variable called active scene, and I'm going to set that to placing by instantiating it. And so now when I call updater, it'll call active scene dot update, and then the same for render. So that should work. The tile size and column count, all that should go up here now because they're no longer used in main.cry. Okay, let's see what that looks like. Grid is used like a local variable, but as an instance field. Did you mean this.grid instead of grid? Line 17. Why, yes, I did. This.grid. All right. Variable keyboard key is I need to also import these in placing. Okay, let's see if that works. So it should work exactly the same way it did before. Okay, so this is cleaner, and you may say, well, it's 6 of one, half a dozen of the other, does the exact same thing, so why would you want to do something like this? Well, if you have a scene object that you can change to something else, that means you can have multiple scenes. And you don't have to worry about it. Like, for example, if I wanted to add a title screen, for example, I wouldn't have to have all the logic for a title screen in my main function. I could encapsulate all of it into a scene object called title scene. And then when the title scene moves to the play scene, then I can just change active scene to play scene. And the new features can be added pretty easily without crashing into each other. In fact, I'm going to do that right now. So placing is just a class, but I'm going to make it a subclass of something called abstract scene, which will be an abstract class. Abstract scene. Crayon doesn't currently support true abstract classes. That's on my to-do list for Crayon 3, but for now, I generally just throw exceptions. And so if a subclass doesn't implement one of the methods on an abstract class that needs to be implemented, it'll throw an exception if that method is called. Ideally, this should be built into the compiler where I can mark methods as abstract, and then if it's not implemented by subclass, then it would not compile, which is the ideal behavior, but that's on my to-do list for the future. So now that I have an abstract class and a subclass placing, I can also add something called a title scene. Okay, what I want to do in this title scene is I just want to show just a simple image that takes up the whole screen, and then it'll say something like press spacebar to continue or something like that. And then when you do that, it'll take you to the placing. So I'm gonna start by saying field background image equals bitmap from resource images title.ping, which is an image that does not exist. Yeah, and then in render I'll say graphics2d.drawImage this dot background image. I want to draw it in the top left corner. Okay. So this image doesn't exist, so I'm just going to draw that real quick. How big is the screen? It is 1000 by 916. All right. 1000 times 9 divided by 16 is 562. So I want to draw an image that is 1000 by 562. Okay, I'm just going to make this look ugly. This game is called Fake Zelda. I have a stylus, so I can write this pretty quickly. Fake Zelda. Press spacebar to continue. Okay. And then this is title.ping, and then I just saved it on the desktop. And I said it was in a folder called images. Okay. So now the image exists. It's created by this static method on the bitmap class and assigned to background image, and then Graphics 2D knows how to draw images onto the screen. So let's try that. The variable bitmap is used, but not assigned to because I forgot to import the image library. Let's try it again. And it didn't work because I'm still starting on placing. So this should be title scene. There we go. So I press spacebar, nothing happens because I haven't programmed it to do that yet. And so just like how the player moves, I can use this input state.is key pressed keyboard key dot space. If that happens, then this dot, I'm going to say switch scene new play scene, which is not defined yet. So I will define that. Oh, I need to import game first because I used keyboard key. Okay, abstract scene. On the abstract scene, I'm going to say switch scene. Next scene. And so any scene can just call switch scene, and then it'll update to the next one. So I'm going to set a field called next scene. And this will be this dot next scene equals next scene. And then main, in this update, before it calls update, it will check to see if the what the next scene is. And then the default value for this is going to be null. And so if next scene is not null, then that means the active scene should be something else. And I need to clear that field if it's something. Okay. So this should work. Press spacebar. There we go. Okay. So next up, the other thing that seems a bit cumbersome is the fact that we're defining this grid in just an array in the constructor, and that's not very versatile. I'd rather have text files where I can just define a map, and then it loads the text from the text file where maybe each character is a different tile, and then it loads that into the place scene. So I'm going to go ahead and do that. I'm going to create a folder called maps, and I'm going to call this one .start.txt since it's the starting map. And we said that there were 16 columns and 14 rows, and the columns around the edge are rocks and everything on the inside is grass. So I'm just going to type that, and I'm just going to choose some characters. X will be rocks and period will be grass. So I'm going to count out 16, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to copy this That'll be the top and the bottom, and then this will be the other rows. I'm just going to, I can look at the line numbers and see that's 14. Okay, so that is the map that we currently have. And so now I want to convert that into a grid of booleans. So I'm going to keep this this dot grid equals new array 2D, but before I pass in column count and row count, I want to read that text file. So there's a library called resources, and this library is has a method called read text. And it takes in a resource name, and so mine is called maps start.txt. And so I'm just going to call trim on it for safe measure, and then I'm going to split it on a new line, and that will give me rows. Actually, I'm going to put these on new lines just to make it clearer. And then each line might potentially have stray white space at the end, or since I typed it on Windows, the new line character is actually 2 characters, and so I want to clean that up. So I'm going to call map row, and then just call trim on every row. And so what this will do is it'll create a grid that, an array of strings where each string represents a row, and then the row, each character in that string represents a column. So the cardinality of this is actually the opposite of the grid, where in the grid the first coordinate is the x coordinate and the second coordinate is the y coordinate. So I can't just have a fancy map function that just converts each row into tiles and then we're done. I have to copy the characters one by one and reverse the cardinality here. The other thing is, because this is coming from a text file, column count and row count are no longer constants, so I should delete those, and instead they are referred in several places, so I'm going to make them fields, columns and rows. And so the number of rows is equal to the length of that array, and the number of columns is equal to the number of characters in any given row. And ideally they should be the same length, but I'm just going to pick the first one to get that measurement. So then I'm going to go through and replace each use of column count with this dot calls, and same with rows. Oops. Okay. And now this was the loop to copy everything, or copy the interior elements set true to all the interior elements. And so what I want to do is loop through the whole array, not just the interior. And instead of setting true, I'm going to check the rows at x and see if it's equal to period. And if it is, then the tile is passable. And then that should make everything else work the same as it did before, I think. Let's find out. Yep, everything works. Okay. So the beauty of that is you can now, like let's say I wanted to add a little boulder to the corner. And it becomes pretty simple. And so when I start adding real real tiles, this is a lot more extensible, so I could add something that's, I don't know, like a bush or something, and being able to edit it in a text file is the way to go. It's kind of look like Tetris pieces. I'm just going to have a little fun here. Okay. So another, there's quite a bit of tile-related logic in this file, and so tiles are going to get more complicated because different types of tiles will have different attributes, and storing all those in a grid of booleans. Obviously, we're going to have to make the boolean something else because right now I can only represent 2 tiles with a boolean. So what I'm going to do is I'm going to create a class called tile, and this will replace our boolean. And each tile is going to take an ID. So this will be X or period, as it currently is, and maybe the coordinates of it. And right now, all we're interested in is whether or not the tile is passable. So I'm going to have another field called is passable. Oh, I think I said walkable earlier, but passable, walkable, same thing. And right now, this is if the ID is a period, and that's it. So here, I'm going to say the tile ID is equal to rows at y at x. And so I'm going to instantiate the tile right here. And so anywhere I was using that, I have to change the fact that it's no longer a Boolean. So right here, where I'm passing it directly into the if statement, that's no longer okay. It's now a tile. Tile equals that. And then this is the updater checking to see if I can move. So I can say if tile dot is passable. This is a lot more readable now. And then here, choosing the color. This is also is passable. So let's make sure that still works. Yes. Okay. And finally, the last thing I want to add is images. And so instead of having this color green, color brown, that's something I want to add to the tile object. So I'm going to add another field called image. And I'll say this dot image equals oh, I should declare the so I'll explain why doing this is bad. So let's say I have some image files, images slash tile slash rock.png or grass.png. So if I send an image and load it like this code gets called every time a tile is created. And bitmap.fromResource creates a new bitmap instance. And so it's going to be loading the image from file quite a few times, and so that's bad. So what we want to do is we want to load the image once per tile type. And so I'm going to put it up here where this is a static field, so only one of these exists per lifetime of the app. I'm going to say bitmap from resource, or I can just copy it here. I'm going to create the image that way. Of course, these images don't exist yet. And then I'm going to say tile.images by id.get. No, I'm going to just say that ID. And I should also set is passable in the same way. Because a dictionary is a lot cleaner than having some magic expression like this in the constructor. Passable by ID. And here I'm just going to put the tiles that are passable. So there's two ways to dereference a key from a dictionary. One is by using brackets like this, and if the key doesn't exist, then that's it'll throw an exception. The other way is to use .get, and this can take in a default value if it's not present. And so most tiles are going to be blocking, and so it's easier to just say which tiles are passable. And so having the grass tile in here is fairly concise. Okay, these images don't actually exist yet, so I need to draw them. My trusty MS Paint. The tiles were 32 pixels by 32 pixels. Grass is going to be green. This screen is kind of harsh. Let's see. Yeah, something like that. And then should have some individual blades of grass. Okay. I'll save that as grass.ping. Okay, and a rock, I'm just going to draw a little boulder with the grass, the same grass color as the background. This brown is too light and warm. Okay. Let's see. Just something like that. It's a little too regular shaped. Cut off the top like that. Okay. Add a little bit of shading. All right. Looks more like a milk dud. So I'll save that as rock.ping. And those are on the desktop. I'll just copy those. Like I said, they were in a folder called tiles. All right. Images, tiles. Yeah. All right, I'm not actually using these yet, so I need to do that. I'm still using color, checking is passable. What I should do is I should have a method on the tile itself called render. And what this will do, it needs to take in a graphics 2D. It'll call draw image, and it'll call draw image on this dot image, And the x coordinate would be tile size times this dot x, and the y coordinate would be tile size this dot y. So remember, this dot x and this dot y are column and row number, and this tile size was a constant that I've defined up here as 32. And once I have that, I just pass in x and y, and that should work once I call tile.render. So I'm not checking walkable anymore, I'm just getting the tile instance, and then I just say tile.render. Then I don't need any of this anymore. Alright, let's see if this works. I keep doing that. Need to import images. Anything else I need to import? No, okay. Alright, that looks pretty good. My collision detection still works. Alright, this video is getting long, so I'm going to stop it there. The next time I think I'm going to update this little red rectangle and get some sort of character that's animated, walks around, and faces in the proper direction. And I will see you next time. Optical